Okay, so good morning, everyone. Today, it will be a bit heavy session because both the problems are like good according to me. So we will just discuss two problems today. So let's just see. So the first problem is finding the pair with a given difference. So actually, this problem is solving these type of problems, but it's a very to start problem kind of a thing. So that's why we are taking it today. So the problem statement is that uh, you are given an array. So like this, you will be given an array. You will be given the size of the array, and you will be given the difference. Okay, then you have to just find that do you have a pair whose difference is this. So here we have 80 and 2. So this pair has a difference of 78. So can some uh, recent placements are going on. So let me just talk in that perspective that when you go into an interview, this is the first thing you do. They give you a question, you just tell them a brute force approach right away. So that's how the internship like interview process goes. So I request everyone to be active here because it's not like you can just magically become active in interview. So that's why I'm just asking you to respond. Okay. So yeah, the approach was correct. This is the brute force way. We just use two variables and we just loop through both of them. Like this is my first variable, like I is here and then j will be here. We will find the difference of these two. Then I will increase j. I will find difference of these two, and similarly, when my I is will be at 2 and j will be at 80, my difference will come as 78, which was desired, and I will return that. Okay, this is the this is my answer. So can someone tell me what is the problem with this approach?
Time complexity.
It can cause a TLE for larger inputs. I mean, it doesn't big O of n square, right?
Yeah. So the problem with this approach is that its complexity is O of n square, right? And space complexity, can someone tell me what will be the space complexity?
Oh, one.
Hello?
No, sorry, big O of n because an array of size n is storing all the values.
Yeah, actually, I just wanted to clear this only. When an input is given, you don't consider that as your what should I say in space complexity. Space complexity is the extra thing that you are doing. Okay,
O
so
of 1.
the space complexity will be O of 1, right? Like I also had this confusion when I was in second year. So let me just clarify that if an input is given, that will not be considered in your space complexity. Only the extra details that you are adding, those will be considered, right? So uh, let's just, can you just think of some better approach to do it? Like one hint will be, can you save something and well, like can you store some values in your array? Like you just read this and you will probably find what I'm talking about. So like what we basically have to find is that two difference of array elements should be equal to this difference variable, right? So can I somehow save all these array elements into some place and then find that do I have an element of array of j plus difference, like do this element exist? Because if this element exists, then I can say that difference will be different between this element and this element will be difference. uh, is my like is it somewhat making sense? I mean, you can think for a minute, then anyone of you can respond.
And we can find a number which is greater than the required difference number,
Okay.
and we can search for other number through which we can difference this number so that we can get the right number.
Okay, so like your approach.
Loya, you're not audible.
Oh, Is it?
Yeah, now you're audible.
Oh,
Yeah,
okay.
now you're on.
So yeah, the problem with your approach is, like, let's say uh, that given difference is 78 in this case. So you said you will find a value greater than 78. Here in this case it is 80. So you can just simply again find 2 and you will be done. It will be an O of n approach. But let's say if I have like 20 values like this, I have 80, 81, 82, 83. So then you can't say na, that which value will be the answer one. I mean, you can have all the n values can be greater than your difference, right? So
What
you
if we
can't
start
be
by sorting with n log n and then we have two pointers, one in the end and one in the beginning, and they slowly converge towards each other till we
okay.
get the
So
difference?
how will you converge?
We start with the we call two pointers max and min. So max it is at the end of the array because it's now a sorted array. It will be the highest value. Min will be the lowest value. And
Okay.
let's say the current difference between max and min is diff. So
Hmm.
if diff is greater than n, we move min upwards, and if diff becomes less than n, we move max downwards.
Yeah, this is somewhat the like this was the main approach which I was planning, but yeah, that somehow like it's correct. But for now we can think of this saving approach. I mean, we will come to that as well, what you are saying. But can you tell me this approach, someone? But actually the reason why I'm talking to like why we are discussing this approach is because this is also very important approach. I mean, it's used in many places, so that's why. So like let me just tell you. So what we do is we make a map. Okay, this is an unordered map data structure. So it is basically like an hash map. You store key value pair. So here, if let's say if I have a key of 20, corresponding to that I can store a value 1, let's say. So what we will do is we will loop through the entire array. We will save all the array of I elements. I mean, we will just increment them, denoting that how many of such elements we have. After that we will find that what is the like, do we have an element known as difference plus ARR of I. So how it will work is, let's say this is our array, right? So corresponding to this array, my hash map will be somewhat like this. For 5 we have 2 elements, for 20 we have 1 element, for 3 we have 1 element, do 1 element, at 80 we have 1 element. So we will store it. Then we will again go through the entire array. We will, let's say we will, if I saw 5, I will say that do I have 5 plus 78 in my array? So I don't have that, so I will like go to the next element. I will, let's say, then check, do I have 3 plus 78 in my array? So I don't have that. Then I will check, do I have 2 plus 78, that is 80 in my array, and I actually have 80 in my array, so I will just return true. So like, is this approach clear? We are basically storing all the array elements that we have in our array, and then simply checking something like this.
Excuse me, Bhaiya.
Yeah, yeah.
Yeah, this could have been better than using an unordered set. You don't need to store a pair in an unordered map. You can do it using a set unordered set also. That would have been better.
Yeah, yeah. I mean, see, I understand. I mean, after some time, I have used map also, and I know that map complexities will be of log n. But like here, we are just talking about the concept. Like this is like the key value pair, hash map kind of a thing. We can
Yeah.
use set as well, obviously. So those who don't know, set is also a data structure. It will be quite easy to use that set, but in some cases, you actually need some sort of a count. So that's why we are just doing it. Otherwise, your approach is also fine. I'm not saying that. So the problem with this approach is that the space complexity will be off, and since you are storing this hash map, right? So to store this hash map, you need to create it, right? So it will be an O of n space complexity. But in this approach, time complexity will be minimum. It will be O of n, right? So this will be the minimum possible time complexity that you can have. So, but now what I want is, I don't want a O of n space and time complexity. I am fine with O of n log n time complexity, but I want a constant space. So like as like Matthew, I think, also mentioned already that we can use some sort of this sort of an approach with when we sort array and then we use two pointer techniques. So his method was also fine. I have used a different method, but our methods both are basically same. So what I'm doing is I'm first of all sorting the array. So my time complexity will be n log n in this case. After that, what I'm doing is I have two pointers. So this will here will be my first pointer, here will be my second pointer. Then I will find the let's say a variable is local difference. So I will find the local difference between them. If the local difference is equal to difference, then I have found my answer, right? If I have, let's say, this minus this is what I wanted, then I will simply return true. But let's say if my local difference, if my local difference is less than my difference, then can someone tell me that why we are incrementing the second pointer, not the first one? Uh, See, in two pointer approach, that's how you think. You think that, okay, when will I increase my first pointer and when will I increase my second pointer?
Standard form, I mean, if you increase the second pointer, you are very sure that you are adding a greater number to the
Exactly,
difference.
exactly. So what he said that, let's say if my first pointer is here, second pointer is here, right? So the difference is currently 1, 3 minus 2, 1. So my local difference is less than my difference. So I have to increase this variable to this pointer. So now, like if I have increased my second pointer, then my difference will be 5 minus 2. So that will be 3. So my difference is increasing, right? So that's how I will keep incrementing second pointer till the point where I've found like the answer or something like that. So that's how we usually work. After that, so this was all for the first problem. So now I'm asking that if in case you have any doubt, please ask right now. Uh, if not, then we will start with the main thing, like today's main agenda, that is dynamic programming. So uh, this is a question, knapsack problem. We will discuss what is a knapsack problem, but before that, let me just like clarify a few things. Let me just first ask here. Know dynamic programming, what it is and how do we use it or something like that. Can someone like tell me that what is dynamic programming?
We break a problem into similar subproblems. We solve the subproblems and use the solution to solve the complete problem.
Okay, yeah, that's actually good, but don't you think that you just told the definition of recursion? I mean, recursion is like that, right? We solve
No,
big
but
problems.
the
Yes.
additional factor involved here is like we store the results so that we don't have to perform the same calculations again and again.
Yes, exactly, exactly. Any other answers? I mean, some new guys are also here, so do they like to answer?
Memoization.
Yes. So, like what I just said might not make sense to most of you, and that's fine. Okay. So, but let me just do one thing. Like when I was in second year, so what I used to think was that okay, so whenever I'm thinking of dynamic programming, first of all, let's make a table and then start filling it with some random order. And if my luck is good, then I will somehow come up with the answer. That was my way of thinking when I was in like uh, in my first second year, first year. So because like I personally never understood what actually is dynamic programming, so that's why I'm just confused. So uh, let me just tell you that what first of all, let me just introduce you to the problem. After that we can discuss that how things are, like how we proceed to the answer. So here we have a simple problem. This is a knapsack problem. For today's session, I have taken this bit basic problem, but for next time we can take a difficult one as well. So let's say we have weight and money array. Okay. So what is like let's say you live in America and someday Mr. Beast came to your house and he said that you have this 15 kg bag, go and take whatever you want, but the total weight should be obviously less than the total weight, the total capacity of your bag. And so what you want to have uh, those items which have the maximum price, right? So I mean, you won't go and just pick up this 12 kg thing whose price is 4. You want to pick up something like this thing whose the weight is 4 kg, but the price will be $10. So like, can you understand the problem? So let me just like define formally. So you have a total capacity, let's say 15, and then you have weight array. Okay, these are the weights and these are the value. So what you want is you want to maximize your value, and given that the corresponding weights, the sum of the corresponding weights should be less than the total capacity. So in this situation your answer will be 15. What 15 means is that 15 is the total amount of money that you can have. So what you will do is you will take this, this, and this uh, elements, and your total price will be 1 plus 2 plus 2 plus 10, like this. Like when you take all of these values, your total sum, yeah, like your total weight sum will be less than 15. So that's fine, but your money will be highest possible. So this is what our problem statement is. So like, first of all, like, I will again ask, in you, do you have any doubt with the problem statement at least? If you have, you can like ask me, because this is very what can I say, important problem according to me. So if you don't have any doubts, we can proceed. Okay, so again, let me just formally say one more time. You have weight array, you have price array. You want to take these elements, okay, such that your total weight will be less than the total capacity given, and your prize money should be highest possible. So this is our basic question. So let me just tell you that if you are sorry, if you are able to solve this problem and understand this concept, then you will be able to solve all these problems. I mean, this is actually true. You can just even the code won't change by much. You just have to change few conditions here and there, and code for all of these problems will also come. So now I think you can understand how important this problem is, that like all of these problems, these 11 12 problems, they all similar to this knapsack problem. So I mean, just uh, pay attention here. So okay, how to start thinking? So first of all, think what is asked. So whatever the problem statement is, just put some time into it, that what is asked to me. Okay, so here what we want is, we want to find maximum value sum, given that their weight should be less than the total constant weight W, right? So now let's say if I pick this element, okay, so for this element, let's say if I have this box, okay, so I have two choices for this box. Either I take the box or I don't take the box, right? I mean, in my final answer also, I have something like that only. Either either I have taken a box, either I have not taken a box. So that's actually the core of the core idea of the problem, that either we take a array element or we do not take a array element. So now this is just the solution. So what we have is, like, let's say if I take this element, this I have taken this 4. Okay, so now I have uh, n minus 1 elements. I mean, I have all these elements, and my total weight will be less than will be like 15 minus 4. So what I just said is, let's say I have taken an element, right? So my total remaining elements will be the n minus 1 elements, right? And my total sum that I can have now is will be that W minus weight of I mean weight of that element which I have just taken. So that will be my remaining constant sum. So this is actually the answer, to be honest. So let me just tell how we came up with this. So there is a function known as knapsack. So here we have an array and we have this weight, maximum possible weight, we have all the n elements. So we have two options now. This is our first option. Okay. Can someone tell me what is this option? I mean, what is this?
When we leave the given element.
Yeah. So this option tells me that I am not taking that particular element. Okay. And can someone tell me what is this option?
We choose the element and now we update our maximum weight for all the remaining elements.
Yes. So now, like in this case, since I'm not taking the element, my maximum capacity will be W only, and my remaining elements will be n minus 1. But in this case, what I'm doing is I have taken that element, so my maximum capacity will be W minus the weight of that element. Since I have already taken an element, so my remaining, like my next possible weight can be will decrease, and my that value will also added. Like whatever I have taken, I have to add that value to my answer, right? So this will be the answer. So that's actually it. So you have these two options and you just have to pick the maximum of these two. So yeah, this is actually the code of it. So like here, let me talk about recursion as well. So how recursion works is you just assume that you will get answer after this, and then you simply just put use that answer. So what you do is you have this let's say a function. You put some base cases. You assume that you will get answer by reducing your input by some amount, and then you just combine that reduced answer in answer of those reduced inputs, and then came up with the new answer. I mean, it might look stupid in the first place, but that's actually the entire concept of your what can I say, recursion. So here what we have is don't look at the base case for now. So this my knapsack problem is my total weight, my weight array, my value array, and my number of elements. So here I have two options. So here what I have done is I have divided the problem into smaller problems, and in from these two smaller problems I'm combining them using this max operator, since I have to take max of the two possible answers, right? And yeah, can someone tell me why I'm using this if else?
If it turns out that the element of the weight array that you're considering is greater than the allowed weight, then we
Yeah,
will definitely have to leave that. So that is the way
exactly,
this work.
exactly. So like let's say if my here my total capacity is 15, but this weight is itself 17 kg, so I don't even have to think about it. I will anyway won't be able to take it. So that's the thing. So we are just ignoring in such cases that element, and here we are simply taking the max of the two parts, and this is the base case. So let's say if I don't have any elements in my array, so do I have to check further? No, I don't have to. Or let's say my total weight is 0, I mean my possible weight is 0. So that case as well, I don't have to check anything. I will simply return it. So now can someone tell me what will be the problem with this code? I mean, but this code is fine. This will work. Your answer will also come with this code. So the problem with this code is that it has an exponential time, because since like for each time we are having two options, either to take it or to leave it. For then now for this node also we have options to take it or to leave it. So like that a tree will like create will be created, and it will have 2 to the power of n nodes maximum. So it has an exponential time. So we don't actually need that. We have to do better. So, now let's just think that what actually is the problem with uh, this approach. So in this approach, we are constantly repeating ourselves. So what my thing is that there are first of all, let's see, there are only two variables that are changing, right? So two variables changing means either my number of elements are changing or my total weight is changing. These two values are always will be the same only, right? So either my total weight is changing or my array elements will be changing. So don't you think I can just store whatever I have found them? I mean, we can save them, right? In some, let's say in some data structure, I have saved all the possible answers that I can have. And let's say, okay, now let me just read it. So knapsack of weight value weight comma n shows me that given an array of size n and total weight capacity w, our best answer will be this knapsack of something something. So, like as I said in recursion, you assume that find this thing. So now what we will do is we will simply store all the weight and n values and return them. So can someone tell me how many possible combinations I can have with n or n and w? I mean, how many possible n and w I can have in my answer? So this will be n comma n into w. I mean, let's say if I have my weight is 3 and my total elements are also 3, so I can basically have 9 type of combinations to show. Like I can have one element, one array element and 3 total weight. I can have 2 array elements and 3 total weight. I can have 3 elements and 3 total weight. Like this, I can actually have uh, 9 combinations. So, but in this case, we are actually having exponential cases. But here we are just, since we are saving these answers, so we will only have n into w type of cases. So let me just show you the code, then you will understand. So what we are doing here is uh, we can use a map to store key value pair. Okay, so as I think Soham pointed out last time, here we are just using map for the understanding. You can use like, no, I think in this case we have to anyway use map. So yeah, so what we will do is first of all ignore this line for now. So what I am doing is for n comma w, since what I said that knapsack of this will return you answer for this thing, right? So what I'm doing is I'm saving my n comma w's answer into an data structure. I'm like you can see here, I'm saving these answers, and in case if I already have that answer in my data structure, I'm simply returning that in this case. So that's actually it. Like this is the memorization approach for the same problem. So what, let me just again repeat here. What we are simply doing is we are saving all the n comma w's which I have found, and then returning them in case if I in future if I anyway encounter them. So can like someone tell me that if they have any doubts or anything, they can ask me. As you can see that like the code has not changed by much. It's just one one word here, one word here, and one line here. That's all. Everything is just same. Like you don't have to think much about it. I mean, just see that okay, I have n, I have w. I'm just saving them, and in case if I in future if I again encounter with similar thing, I will simply return it directly. I don't have to again calculate that tree. So like just note it for some time and like practice few other problems which I have written in the PPT, and then you will be able to understand it. So now in the end, let me just tell you what that table actually meant. I mean, for most of you, when they saw dynamic programming, they would have saw something like this. You have a big table and everyone is just finding values. Like what I used to do is I used to remember this thing, and then I used to just say that okay, I will either take this or this or this. So like this, I never actually understood what dynamic programming is. So the tabulation method is just some simplified version of this. I mean, this memorization method is to understand, but what we are doing is getting the same thing 2D array of I comma j. So what we tell is that our first I elements and my total capacity is j, then what I'm just finding this answer by the previous calculated answers. So this is my actually entire logic for the tabulation method. I have an array of this size, n plus 1 size, and w plus 1. So y plus 1 is because like for zeroth element we don't have anything, right? So these are the base cases. So these base case, as you can see here, these base cases are basically this. So this part of thing, like this, these base cases are converted to this. Like I when I don't have any element or and when I don't have any weight. So these are converted into this, and then what I'm doing is I'm going through all the array elements and all the weight, and I'm just, if my weight is, let's say, less than this, then I'm just finding dp of I comma j is equals to I minus 1 j minus this, I mean this thing. And like, can someone tell me what is this case, what I'm doing in this situation? So in this situation I'm taking the element, and in this other situation I'm just leaving the element, and I'm taking the max of both of them, and after that I will simply return answer. I mean, I can understand that some of you who just saw this for first time might not understand it properly, but just put some time into it and you will slowly start understanding what this thing actually means. So now just ask me, do you have any questions? uh,
What are your suggestions? Should we go with the naked method first, or should we directly start the tabulation approach?
Yeah, so see, if you, let's say, you're very experienced and let's say you just saw a problem with this approach, like, yeah, there are two things. One thing is, if let's say you are in some coding contest, then if you know the tabulation method, then you should go with this. Okay, but this will be like very rare event, to be honest. You, most of the time you won't be able to like recognize such things. I mean, if let's say subs, a very similar problem appear, then you can directly go with this. But otherwise in interviews also you have to start like this only. You have to first come up with some brute force approach, just yeah, come up with some recursive approach, then you have to come up with this tabular this memorization approach, and after this you have to come up with this tabulation method. That's the normal process in interviews and all. But in coding contest, if you can do this directly, then yeah, you should go ahead with this directly.
Sure, thanks.
Yeah,
Also, one thing is that memorization is very slow. I mean, in most of the
yeah,
cases, you won't be passing the test cases.
yeah. So like, what the problem with the memorization approach is, see, this approach and this approach, they both are same in the time complexity. Like both of their time
Yeah, the
complexity
maths
will
cannot
be,
take the time.
yeah. The problem is that here we are doing so many recursive calls, right? So when you do recursive calls in your system, you make a stack, and like everything happens. So because of that reason, usually memorization is takes more time than your, like, this approach, tabulation method. So any other questions? Someone said something, right? Okay, so I mean, that's all from my side. So one thing is, you have to solve many DP problems if you want to master it. I mean, it's like you have to solve at least for problems if you want to like become a champ of dynamic programming. But I can understand like solving 100 problems. Try to do all these problems by the end of the week, because all of the problems are almost similar. Like, let me tell you what this unbounded knapsack means. So unbounded knapsack is means is like, in this case you can just take this element, right? So once you take it, you can only take it once. But in unbounded knapsack, you can take it as many times as you want. So this is your unbounded knapsack. So like this, all of the problem will have almost very similar thing. So like, try all these things, you will find them interesting. So I will share the slides, maybe just share now only. So like, as I said, like, try it, and if you feel that you are not able to understand, then you can always ask here. So now again, do you have any doubts?
Yes, I have a doubt in the answer.
Yeah.
What if we created a new array with whose ith element is simply cost per unit weight, and then we sort that array and find the most valuable item in terms of cost per unit weight, and we simply go take the most valuable item, the second most, and third most, and so on.
uh, like from what I understood is that you are saying that you can make an array by like by the ratio, right? Or some did you
Yes.
said something like that?
Yes, cost per unit weight.
Okay, so what you just said is it's known as fractional bounded knapsack.
Fractional.
So yeah, so in fractional DP, that's not actually a DP. It's like a greedy approach, but uh, like let me tell you where that thing works. So let's say if you have honey, okay, and then someone said that the price of like 10 kg honey is this, and you can take 1 kg as well. So in that situation, your approach works. You can simply take the ratio of weight by money, and then you can do it. But in this case, either you take it or you leave it. You don't. There is no middle ground here. Okay, you just either you can take this thing or you can leave this thing. There is, it's not like you can just in these 12 kgs you can take the like 2 kg first 1 kg and leave the rest 11 thing, right? I mean, you can't uh,
Yes.
tear a book into half. So that's why we can't use that ratio approach. Is does that answer your question?
Yes.
Okay, so any other questions? Okay, so again, I'm saying is like try all these problems. They are very important. Okay, and once you are done with these problems, next week we can maybe start some new DP approach. So like, let me just, to be honest, there are like 3, 4 major DP problems, and from those major problems, you have many sub problems. So like this is one type of problem on knapsack, with which you can solve all these type of problems. Then there is another approach, like there is another type of DP problems that are like matrix chain multiplication. So once we teach you that, after learning that thing, so you can again have many similar type of problem, and then we have like longest increasing subsequence type of problems, and those problems also you can try. Once we have done this, from next week we can do some other DP type of problem. So I request you to first practice all of them, otherwise it will be very difficult for you. So if you don't have any doubts, then I think we can stop. Okay, guys, then we can leave. Thank you.